engineer in Service Private Limited in SI Squared. Today I am introducing my experimental Saturday tool OPA with Terraform. So first of all, what is OPA with Terraform and Gatekeeper? So OPA is open source general purpose policy engine is designed to evaluate many software systems like Kubernetes, gateways, CI/CD tools, and Terraform. So it is currently a part of a cloud native computing foundation (CNCF). So OPA with Terraforms and OPA Gatekeeper. So while OPA is enforcing a streamlined function with gatekeepers, and gatekeeper is an admission controller to extend the policies to open policy agent for enforces the policies for real-time clustering like creation and updation of a cluster. Now let's move to the problem statement of OPA.
Now starting with the problem statement. So implementation policy as a code with open policy agent OPA and Terraform. So here first of all background. So what is the problem statement? So organization today manage a complex cloud infrastructure using infrastructure as a code ISC tool like Terraform. So Terraform allows defining, deploying and managing infrastructure resources across various cloud providers and on-premises environment. So however, as infrastructure skills ensuring compliance, security and governance across all resources becoming challenges. So what was the problem? So problem is to establish a reliable and scalable method for enforcing a security and compliance policies across all organizations infrastructure deployed using Terraform. So this problem statement focusing on using open policy agent OPA to address the challenges. So what are the challenges? So first of all, policy enforcement. So without a systematic approach, enforcing policies such as access control, data retention and compliance standard becomes manual and error prone. And second one is dynamic infrastructure. So dynamic infrastructure can frequently due to scaling or update our cluster as well as our Terraform, so ensuring our policies adapt to these changes in critical. So next is auditability. So tracking changes and compliance status across the infrastructure is essential for auditing and accountability. Next is cross-cloud compatibility. So many organizations use a multi-cloud or a hybrid cloud environment, so requiring policies to be a cloud agnostic. And next is developer productivity. So developer productivity is the policy should not hinder development and deployment process. So they should be integrated seamlessly into the CI/CD pipeline. So solution is involves to integrating an open policy agent OPA with Terraform to enable policy as a code for infrastructure management. So policy as a code allow organization to define, version, test and enforce policies in a standardized and automated manner. So here is the solution of OPA with Terraform. So first of all, policy enforcement. So OPA allows you to define fine-grained policies that specify what is allowed and what is not within your infrastructure deployment. So these policies can cover various aspects of your infrastructure such as security, compliances, naming conventions and resource types. So next is declarative policy language. So we use a declarative policy language called Rego. So all work of our policies in Rego language. So Rego allows you to express policies in a human-readable format. You define rules that describe the conditions under which the request is allowed or denied. So next is integration with Terraform. So OPA can be integrated with Terraform to evaluate policy against your Terraform configurations. So these integrations ensure that your infrastructure code adheres to the defined policies before deployments. Next is validation and compliance. So upon policy agent, OPA can validate your Terraform plans and configurations to ensure that they meet your organization compliance requirements. For example, you can enforce policies that restrict the creation of resources with public IP addresses or require encryptions for certain data stores. As well as dynamic real-time evaluation. So open policy agent can dynamically evaluate policies in a real time, which means it can respond to change in your infrastructure and adapt policies accordingly. This helps to maintain a compliances as your infrastructure evolves. So open policy agent OPA is a declarative policy language that can be used across your cloud ecosystem to ensure controlled deployment. It has increased in popularity with the Terraform community as way to check their Terraform plans and ensure DevOps teams are deploying according to organization standard.
So here is my implementation of my tool OPA with Terraform. So first of all, here is the architecture of OPA with Terraform. First of all, user is a workspace where I was creating a 3 files. First of all, deployment.rego file where I was implementing my policy. Second one is main.tf file where Terraform code, and third one is my YAML file where I write the mail. So in this scenario, This is the Terraform workspace where I was created files, and there's a plan. Plan command is, first of all, we are executing a Terraform init command for initializing our all files and configuration of Terraform. Then we have applied Terraform plan. We have to plan our all executive commands, all scenario in our Terraform. Then we run the task. Third one, first of all, initialize the command, then plan, and then apply. Then we can apply our commands. Then main.tf file and log.html file will be created. Then in this advisory of pass and advisory of failure, in this scenario, where this is a scenario that my policy is pass or fail. My policy is pass, then apply our policy in our Kubernetes and as well as Terraform. Then failure, then fail our policies. So now we move to implementation. So first of all is a deployment.trago file, where in this file, what was I created? This policy deny the image of Nginx latest. First of all, this is a package.openagent that deny these images. Input kind, we have created a pod, and input operation create, and input user, system user account. Here is the default user input creations, and this is the container, input of container, and container name Nginx. And we have put the image Nginx latest. In this scenario, policy is not any user who want to make a Nginx latest image, and this latest tag image where can't be implement and can't be take a Nginx image latest in our Kubernetes code in as well as Terraform. So here is our YAML file in Kubernetes. We have created a pod with the name of metadata in the name of test, and the labels we have assigned a Nginx image, and specification we have entered the containers in the name of Nginx latest image, where we can apply kubectl apply -f test.yaml. So image will be displayed like image will run because we have applied Nginx latest. So here is the main.tf file where we apply triggers like always timestamp run, and for business commands operation we create a user slice with the name of Nginx image, and this is the policies where apply Nginx code.yml, where latest tag is not created, not in mentioned in our policies. The Nginx image will not run. So command is kubectl apply -f Nginx code.yml. They will create our policies and deny our result. So this is my implementation of my code.
So how we can discuss the use cases of OPA with Terraform. So first one is prevent unauthorized resources creation. So in this use cases, under of enforce security and compliance requirements. So use OPA to ensure that only authorized users can create our resources in your cloud environment. So this is the prevent of unauthorized resources creation. So next one is comply with industrial regulation. So OPA can help you comply with industry regulation such as HIPAA or PCI DSS by enforcing specific configurations requirement. It also enforces the security and compliance requirement. Next one is enforce resources tagging convention. So in this use case, we have for implement governance and control. So use open policy agent to require that all resources be tagged with specific information such as the owner, department, or applications. Next one is control resource allocation. So in this use cases, for implement governance and control. So control resource allocations define policies that limit the number of resources that can be allocated to different teams or projects. Next one is automated infrastructure deployment. So in this use case, form automated workflows and approvals. So use open policy agent to automatic infrastructure in deployment based on a predefined policies to make automate our infrastructure deployment. And next one is enforce approval workflow. So in this automated workflow and approvals require approval for certain types of infrastructure changes such as creating resources in production environment. And last one is integrate with the CI/CD pipeline. So in this automate workflow and approvals, open policy agent can be integrated with your CI/CD pipelines to automate compliance checks and approvals. OPA with Terraform. So the integration of OPA with the Terraform offers several significant and very positional benefits for enhancing the management and security of your infrastructure as a code deployment. So first one is automation of governance and human-readable policies. So those benefits are come from policy as a code. So first of all, automation of governance. So OPA allows you to codify governance policies as a codes for enabling you to automate policy enforcement and validation within your Terraform workflows. And human-readable policies to OPA policy language Rego is a human-readable and expressive for making it easier for both developers and operators to define and understand the policies. Next one is prevention of misconfiguration. So this policy is under from policy enforcement. So one policy agent ensures that Terraform deployment adhere to defined policies, reducing the risk of misconfigurations that can lead to security vulnerabilities and compliance violations. And next one is proactive security. So this policy is under from policy enforcement. So this policy are evaluated before changes are applied. So providing proactive security controls and risk mitigations. And next one is custom policies. This custom policies is like flexibility and customization. So open policy allows you to create custom policies tailored to your organization specific requirements, encompassing securities, compliances, naming conventions, and more. So next one is extensibility. So this policy is under form flexibility and customization. So it's the main benefit of our OPS. You can extend the open policy agent capabilities by adding custom functions, data sources, and integration with external system, providing adaptability to diverse use cases. And next one is real-time decision making. So in this policy, real-time decision making and dynamic evaluation. So OPA evaluate the policy dynamically in real time for enabling it to respond to changes in infrastructure and adapt policy accordingly. So many of the policies like infrastructure evaluations, compliance assurance, as per your infrastructure evolves for open policy agents, so helps to maintain compliances and security by continuously enforcing our policies. So those are the benefits of open policies agent.
Comes to the conclusion, the OPA with Terraform. So now today, organization manage the complex cloud infrastructure using infrastructure as a code. So Terraform allow to manage deploying and defining the policies in a PAC, policy as a code basis. In summary, policy as a code OPA with Terraform. OPA with Terraform will combine infrastructure management to ensure the policies and enhance the security and providing the robust solution for multi-cloud environment.
Cultivation culture. With our Terraforms to make our movement better, we focused on how to help our colleagues to practice cultivations. Every programs and rules definition created a socialized cultivation behaviors to help people understand how they can bring cultivation to life and to provide them with a common language to describe actions related to cultivations. One behavior does not exclude another, and all such peoples are invited to explore the behaviors, play and practice with them to find inspiration for their own way of cultivation.